called Polynomial Power and Rational Functions. That's a lot of stuff. That's 3 different chapters that you did in Algebra 2, and we're kind of jamming them all in one. So we'll definitely have some graphing in this chapter, kind of reviewing everything. You don't have to write this part down, all right? You don't have to write what you're working on. But today we're going to learn about polynomial functions. What is a polynomial function? Graphing linear functions, which should be pretty easy, and quadratic functions and quadratic form. And again, they're all like real uses for this, and we'll do some story problems to show you this. But that's the plan for today. Boys, settle down back there. I'll have to separate you as well. He's not here today. All right, we talked about polynomial functions before. I wrote it out for you, a little bit less scary than the book writes it for you. But any polynomial function can be written in this form. And n just stands for the degree of the polynomial, right? And I'll write a real one up here, but this is how, like, official math people write polynomial functions. A sub n, x sub n. They're x to the n. That's your degree. That's your leading coefficient. And then we always write it in descending order of exponent. So this is the next one down. And we just go on and on all the way until we have no x's left. And if that scares you, around that, you can write a real polynomial function would be like 4x to the 4 plus 3x squared minus 2x plus 7. Right? We start with the biggest degree and we count down by 1 until there's nothing left. I still have those tests on Friday.
Not very good.
I know. The fact that people act like they're terrible makes me even less motivated to grade them.
I thought I did good.
I felt like I understood what I was supposed to do. I couldn't do the simple math. Like, I could do, like, I could get it where I was supposed to, but I couldn't do, like, fraction or, like, I don't know.
I thought most of it was alright, except like the T thing. I just totally forgot.
Yeah, I think a lot of people forgot about the T thing.
That wasn't good.
I thought the T thing was really, like, isn't that where you just T out?
Parametric, remember?
Then
The last question. Triple XY chart.
Triple X.
XYT chart.
I did not XY charting.
2 and 1.
We also say for a polynomial function, a has to be a real number, and n has to be an integer. But people forget what integers are, so I kind of wrote what it means to be an integer. Means it has to be kind of like a whole number, but a negative is included. N is not allowed to be fractions, decimals, negative numbers, negative exponents, right? So your exponent has to be an integer, but people forget what integers are, so those are my extra notes. Kind of a mess, right? If you know what an integer is, you can just say it's an integer, right? But I feel in past years I've learned people don't know what integers are. No fractional exponents, no negative exponents, no decimal exponents. Fractional exponents. We're doing fractions, but not exponent fractions. Because that makes like square roots and stuff. And a sub n is our leading coefficient, or whatever number is with the highest degree is your leading coefficient. That's the other big thing. So part of your homework today is as easy as saying, is it a polynomial, yes or no? And if it is, what is its degree and what is its leading coefficient? And if you forget that, then I'll review it with you in a second.
Okay, so it'd be 4x, 4 would be.
Yeah, so for this one, the highest degree would be 4, and its leading coefficient would be the number in front of that, what happens to also be 4.
So it's just 4.
Right. The leading coefficient is just the number in front, not the x included.
Now, why do we have to have the sub n there?
That's just how they write it on here, right? A sub n just means the number that goes with the power n. That's all. Like, no notation of it. Cause see, like on this one, they write it as a sub n minus 1. It's because they use a all the way through here, but they're really different. A is a different thing every time. Kind of just some weird notation.
So it's just saying that they're all different numbers and all those things.
Yes, that's what it's saying.
They could just like A.
B. They could, but they don't. I know. As people like to do some crazy notation. Aaron.
What is that variable
You can't have that. Does not equal variable in denominator. You can't have a variable in the denominator in a polynomial function either, because a variable in the denominator is the same as a negative exponent. Those are just all my little rules here. So let's look at some things that are polynomials and some things that are not polynomials and practice this. We're okay with this. And this is the first part of your homework. Determine if the function is a polynomial function. If so, state the degree and the leading coefficient. If it's not a polynomial function, we don't say it has a degree or leading coefficient. We just say it's not a polynomial function. Yeah? Do you want to make study?
We got our stuff, like our drawings,
Oh, that's nice.
architecture stuff, coloring stuff. Oh, it's there's 2 different rules, like 9 sides. It's not fun.
Negative 9 sides.
Well, it has like the 3 thing, like so like it goes up and then it goes down and then it goes down on the side, and on each little one there's 1, 2, 4, 5, 6. Sorry, there's 6 different things on this roof. Oh man, it's a pain.
Is this a polynomial function?
Yes, ma'am.
Yeah, as long as nothing weird's going on, no negative exponents, no fractional exponents, no x in the denominator, it's a polynomial function. So, yes, it's a polynomial function. Why am I using blue? What is the degree of this polynomial function? The degree is the highest exponent, which in this case happens to be 1. So, x first. And the leading coefficient, I like to say LC for leading coefficient. Many people think the leading coefficient is always the first number. It's only the first number if it's written in descending order. The leading coefficient is the coefficient in front of the highest exponent. So it's not 9, right? It's 2. Leading coefficient is not necessarily the first number, not necessarily the biggest number. What about this one? Is that a leading, is that a polynomial function?
Whoa. What are those?
Just settle down. Let's do these problems first. I'm just trying to get us ready.
Sweet.
And
Those are includers.
Is f of x equals 13 a polynomial function?
Yes.
It is a polynomial function. What is the degree of this polynomial function?
0.
Yeah, there's no x in there, so that would be a leading coefficient of.
So all of these are always going to be better than a negative exponent like a fraction or something.
Right. What about the leading coefficient of this one?
0.
That's kind of tricky, right? Oh, I know. I used to think it was 13 because, there's no 0 there. But the book actually says it's.
Okay, so it is a polynomial function
gonna say
because
that.
it has no
Sorry.
whatever those exponential fractions or
Right.
so even if there's just one number in there.
Yeah, because that's still a polynomial function. It just has no x in it. It's just a constant function. Hold on, I gotta verify this before I tell you to put what to put on this. Because I'm afraid I'm going to be wrong.
Hey, we should make a Do we know anything about
Just do not mess with that right now. You're getting ahead of yourself.
I don't know.
It's like, oh, really?
What's going on with you?
Okay, yeah. The leading coefficient should be 13 on this one.
Hey, I told you.
Not 0. Because we could think of this as 13x to the 0. So the degree is 0, so the number in front of that's 13. We just don't write x to the 0 on that. Okay? That was a little tricky. What about this one? Right? This is 1 over x. That's a rational function. That's the same as saying x to the negative 1. That's why we can't have number or variables in the denominator. So this one is not a polynomial function. I know you're just going to write no on your paper. I'm okay with that. So I think the next one is one that we're going to use our little clickers on. So have you guys all used these before? Did I even get to this row? I think I stopped at some point. Well, no, I just get distracted with. So turn it on if you haven't already done so. Oh, I wonder if I even. And then it should say join Dixon. If it says join Ag Room, you need to add a new find a class. And then I have your own little number here, your ID number. So after you join it, it's going to ask you for your ID number, and this is your ID number for my class. So find your number.
So we hit enter Dixon.
Yeah, so join Dixon, and it should join.
Actually, no, you're not. You're 30.
I'm 30.
And then you type in your number, and it should say, "Are you so and so?" And you hit yes. And then I have to start this question. So give me a second here.
Why does it say car?
Hold on. All right, let's see if this works. So I just started this, which means that you should get to sign in, say yes, that's you, and then this says which of the following is a polynomial function, and you're going to hit A, B, C, or D, and you're going to hit enter, and then we'll see if we all understand what polynomial functions are. So which one of these is, not isn't, a polynomial function? A, B, C, or D, hit enter, and then we'll see if we agree or disagree.
What if it says free and not sweet?
Yeah.
Oh, yeah.
Oh, you just give me the answer.
Oh.
Then see, mine did the same thing.
That's all right.
So that's
The question set says no.
to go.
I know, but I didn't get it right.
I think you just have to hit it enough times. I think hit it.
Oh, no, no, no.
I don't get it right now, so I'm gonna get it right.
I'll try it.
Will that work if you hit 3? Did anybody get the change of seat?
Well, in the brackets it says 1, 2, 3.
I can read it highlighter.
Oh yeah, just hit 3. That's
Thanks
one.
for like.
Maybe you just hit. I don't know. It says C on it, so hit.
Answer's 4.
We'll see. And look at this. It shows me who's still waiting to enter their.
I'm off the
Hey,
list.
Tyler, why don't you answer?
I did.
Obviously not.
Says you have entered. Oh, all students have finished. So then I can stop the question. Oh, everyone got it right.
I wonder why.
They go to cheater.
It's alright, it's alright. This is like we're just practicing. We'll use these more as the year goes on, but this is kind of our little practice. I think it's all we're using it today, so you can
Oh.
I know, sorry. It's hard to write, like I can't have you write an equation on here, so you know.
We went through all that trouble for just one problem.
It's alright. Well, now next time we'll be faster at it, right?
Be cool if we got signature.
So C was the right answer. This has a square root, this has a negative exponent, this has x in the denominator. So that's why C was the right answer. Okay? Got it.
I thought we were gonna do one of the things, and I was like, I don't know how to do that.
That's why we can't do these anymore right now.
I'll just sign out. I don't want anybody
You don't even
messing.
have to sign. If you turn it off, it signs you out automatically.
I didn't do that.
I don't want anybody hacking my account.
I know, and I can keep track. We could actually even do a quiz on these, and then it's already graded. How about that?
That'd be alright.
But then we can't have people yelling out the answers.
MLA.
This dumb pencil.
That's why we practice. Aaron, I love those pencils. Don't make fun of them.
No, it's mine. They ain't got a oh. It's beautiful. Yeah, but at least it's worth stuff for it. You can't even get it for it.
All right, what about this one? It says write an equation for the linear function f such that f of negative 1 equals 2 and f of 2 equals 3. They're telling us that that's linear, so do we know how to write a linear equation? We have like a form that we use for linear equations. Y mx plus b. Good old mx plus b, right? When they give you this, what are they giving you?
One B. Alright.
Slow.
Oh yeah, slow.
They're not giving me slope yet either, right? They're just giving me points, right? Like this, when we say f of x equals something, this is the x, this is the y. So when they write stuff like this, it's like they're giving you points. which you're going to need to find the slope.
Wait, I always thought X.
Well, it does. Like f of x equals y. So this is the y. That's the x that they're plugging in. See what I'm saying? So this is like saying when x is -1, the y is 2. And this one's saying when x is 2, y is 3. So function notation are giving you points on your graph. Mason, focus. I mean, not Mason. Aaron, focus. Sorry. Quit talking about tennis. So these are my points. We should be able to write an equation. We do need slope. How do we find slope if we're given 2 points? Rise over run. Y is on the top, x is on the bottom, so 3 minus 2 over 2 minus, yep. Rise over run. The rise is the y's. Good way to remember it. So my slope would just be 1 over 3. Right? Because you're minus a -1 makes +1. So I have my slope, so I could write y equals 1/3 x plus b. How do I find b? Yeah, they gave me 2 points. Plug in one set of points for x and y. That's what these are in x and y, and you can solve for b. It doesn't matter which one you pick. I'm going to pick this one. So I'm going to plug in 3 for y. I'm going to plug in 2 for x. Dang it, I was hoping it would work out so nicely, right? And I'm going to solve that for b. So I get 2/3 plus b. So I'm going to subtract 2/3. And I don't care if you give me a mixed number. I know your calculator will give you a mixed number or an improper fraction. But let's try to stay away from decimals, especially if it's a repeating decimal. 3 minus 2/3 would be 2 1/3, right? Which would be 7/3. Or 2 1/3. So don't forget to actually write the equation, like put it all together. So your answer should be y equals 1/3 x plus 7/3. Linear equations. You've been doing that a long time. The big thing is people get confused about the f of 2 stuff. It's just an x and a y. Questions about that? The rest of the stuff that we're doing is dealing with quadratics. So let's remind ourselves of the vertex form of a quadratic equation. We dealt with quadratics a lot in the previous chapters, but we've always been dealing with them like this, the ax squared plus bx plus c, and solving it. But also remember that you can write it in vertex form, which makes it really easy to graph. And you just have to remember what all these things stand for. So this equation is standard form. This is vertex form. And if you remember all those lovely conic sections you did last year? H and K, they all kind of had some similar format to this. So remember that the vertex is at the point HK. So if you have it in vertex form, you know where it starts just by looking at it. You also can use the idea of transformations to help you in vertex form. Think about K tells you how much a graph moves up and down. H tells you how much it moves left and right. A tells us a couple things. Whether A is positive or negative tells us if the graph opens up or down. So if A is less than 0, then our graph opens down. I'm just going to draw a little graph like this. And if A is positive, then our graph opens up. And also A can stretch and shrink our graph if it's bigger than 1 or smaller than 1, right? Like a 1/2 would be a stretch, 7 would be a, no, I think I did that backwards. 1/2 would be a shrink and 7 would be a stretch. But putting things in vertex form and graphing is the rest of our homework today. I think I just summarized the rest of this, so let's see if I need to read this. Parabola, HK. Oh, I forgot axis of symmetry. We might want to say that. Axis of symmetry, which remember is that line that cuts your parabola in half, is the line x equals whatever h is. But yeah, I summarized everything else a lot shorter than this stuff, so we'll just cover that back up. What's wrong? What was on her?
I had a little spider in my hand. I was like, little spider, little spider. And Allison just like, no.
Okay, can I go from this? Alright, so it says describe how to transform the graph of x squared into f of x, and then we're going to sketch the graph. Really nice when it's in vertex form. Very similar to what you should have been doing on your test Friday a little bit, maybe. Like I said, I feel like vertex form is just using the stretches and shrinks and the horizontal shifts and vertical shifts a lot easier to instead of the standard form. But I do believe you have a question or two on your homework that asks you to describe how to transform it. So again, it's just practicing those transformations. This is our little parent graph here, x squared. What does this plus 3 out here mean? Going up 3. What's a number inside mean? And actually minus inside mean?
To the right.
Yeah, we're doing the opposite in here, so that we could say this graph is shifted right 2 and up 3. And this 2 out front, a number out front is going to be a vertical, right? And this is bigger than 1. I think that should be a vertical stretch by a factor of 2. So I'm going to say that. Vertical stretch by factor of 2. For the most part on your test over this chapter, I'm not going to make you like describe that in words, but today they're kind of just re-emphasizing that. Because you should be able to graph this using the fact that looking at this, we could say that the vertex is h and k, and remember we always take the opposite sign of the inside, so the vertex is at 2, 3, which is exactly what we said here. Instead of starting at 0, 0, we're going to go right 2 and up 3, so that's where our new vertex is. And just like before with the stretches and shrinks, if you're not sure what happens next, pick a point next to your vertex. But normally with a parabola, when I go over 1, I go up 1 on either side, right? But because there's a 2 in front of that, when I go over 1, I'm stretching it by 2, so I'm going to go up 2 on each side, right? It's going to be a thinner parabola. If I go over 2, normally I go up 4, but how many would I go up on this one? 8, and I don't have that on my graph. 1, 2, 3, 4, 5, 6, 7. Oh, you don't have to make it on yours. I'm sure you don't have it that far. But it's a much thinner parabola. But graphing in vertex form is way easier than graphing in standard form because you can tell what the vertex is by just looking at it. Questions about that? Like quadratics are in like every, like we did it in chapter P, we did it in chapter 1, now we're doing it in chapter 2. They just never go away. The big thing that we have to make sure we know how to do today is if it's not in vertex form, do we know how to get it in vertex form? So that's my last examples here. So it says, rewrite the equation in vertex form, state the vertex and the axis symmetry, which if you put it in vertex form is really easy to do. Right, so we want to take something that looks like this, and we want to write it as ax minus h squared plus k. So we want to take something that's not a perfect square and make it into a perfect square. How do we do that? How do we turn something that's not a perfect square into a perfect square? Complete the square. Good old complete the square. So people that hate completing the square, when solving quadratics, can't get away from it in vertex form. Like, you have to complete the square in order to put this in vertex form. The big thing that we have to remember is that we're not solving this, so we don't ever move stuff over here. So we have a couple of things that change when we complete the square on this. First thing that changes is normally when we complete the square, we take this c value and we add it over here, right? But there's nothing to add it over, so it's kind of like we just stick it down at the end. So when I do this, I'm going to kind of group together my x squared and my 4x, leave a spot to complete the square, and just kind of kick that minus 5 out here to the end. Because you can't add it to f of x, it's just f of x over there. And then other than that, the completely square part is the same. We still take half of the middle number and we square it. And so what number would go right here? Yeah, half of 4 is 2, and 2 squared is 4, so I add 4 right there. When we solve equations, when we add 4 to the other side, right? I can't add 4 over here, so you have to kind of undo it over here. If I add 4 inside the parentheses, what do I do outside the parentheses to cancel it back out? Yeah, because if you add 4 and then you subtract it back on the same side, it's the same as if you added it to both sides. So that's the big thing. Remember to do the opposite on the outside. You have memories of this? And now the reason we did this is that's how we complete our square. That should always factor into half of the middle number, and half of 4 is 2, so x plus 2 squared, and then negative 5 minus 4 is negative 9. We're supposed to say the vertex and the axis symmetry. What would my vertex on this one be? Negative 2, negative 9, because remember, it's x minus h, so you always take the opposite sign on the inside, the same sign on the outside. And axis symmetry, they want us to write it. We're not really going to do a whole lot with it, but it is an equation. It's the vertical line, so it's x equals, and it's what cuts the parabola in half right at the vertex. So it's always x equals that h value. Make sure you write it as an equation. That's the easy part, right? The hard part is when there's a number in front of x squared, or it's not an even number, right? And that's where things get a little bit uglier. So let's do a couple more. They can't all be this easy. And this is where I'm a big fraction fan, and I really try to convince you to keep fractions as well. Remember to complete the square, you can't have a number in front of x squared besides 1. When it's an equation that we're solving, we would just go through and we would divide everything by 2, right? But you can't divide f of x by 2. So do you remember what we have to do on this one? Right. I can't divide because it's f of x, but I want to like separate the 2. So instead of dividing, could we just factor that 2 out front? The nice part is 7 is not divisible by 2. We don't have to factor it out of 7. Like, we only have to do it for the part that we're completing the square on, like kick that 7 out to the end. So I'm going to take a 2 out of just of the x's, and I'd be left with x squared plus 3x. Leave my spot to complete the square, and I didn't do anything to the 7 because I'm not completing the square with the 7. It's just extra at the end. You with me on that part? Now, this is the other ugly part of it, is if your middle number is not even, when you take half of it, you're going to get a fraction. But remember, to take half of a number, you just put it over 2. So I'll just put this up to the side here. But half of 3 is just 3 halves. And then to square a fraction, all you do is square the top and the bottom. So I would just be adding 9/4, right? Practice with fractions. They're good for you. And if I add 9/4 on the inside, what do you have to do to the outside? Subtract, but here's the other fun part of this. There's only a 2 out in front here, right? And so if you were really going to simplify this problem all the way down and you knew what x was, you really have to take all this times 2. So when you subtract 9/4 on the outside, you can't just subtract 9/4. You have to multiply by that number in front as well. Do you have any vague memories of doing that in the past? So you have to kind of keep it balanced. So if you factor a number up front, you got to multiply it over there. Some people like to just multiply it and then write that one number there. I just always have the habit of if I add it on the inside, I subtract it on the outside, and then I multiply. That's all the work there. Now it's just simplifying. Half of the middle number, which I know is just 1.5, but I'm going to write that as 3 halves squared. Watch your math out here. Some people just take 7 minus 9/4 and then they multiply by 2. Right? That's not following order of operations. If you're going to do it on your calculator, type all this at once on your calculator because your calculator will multiply and then add. But if you're not doing it all at once, you have to multiply before you add 7, right? So don't miss that part out there. If I took 9/4 times 2, that's just going to be 9 halves, I think, right? So I could cancel that. Yeah. And 7 minus 9 halves, that would be 14 halves minus 9 halves, which would be 5 halves, or 2.5. And I know your calculator does that for you. I just like to show you that fractions aren't the worst thing in the world that you all think they are. So I just got a common denominator. 5 halves. That one wouldn't be that fun to graph, but we could. It would have a vertex at negative 3 halves, 5 halves. So at negative 1.5, 2.5. And our axisymmetry would be x equals negative 3 halves. But you're definitely going to have some on your homework today. I can probably promise you on your test you're going to have a question that you have to complete the square on that's going to give you a fraction like this. Not awful, just a little more work. I got one more, just like this, just for practice. I'll let you do this one. Oh my gosh, just kidding. But it is one more you have to do for me, though, and I'll give you a piece of paper. This is like your test, not really a test. You're going to put this in vertex form and state the vertex. And here you go, you're going to do it on this piece of paper. And then you're going to turn it into before you start off. You can if you want, but I didn't say you don't have to. Okay, you gave you an easy one. Put this in vertex form, state the vertex, and then when you're done with that, you can give it to me, and then that's your homework at the bottom. I need to make copies of the new assignment sheet, but this is 2 one-day one.